Experiments can show that what we think of as particles, like electrons and atoms, actually behave like waves. Waves of probabilities. This is the foundation of quantum mechanics. The famous double slit experiment illustrates this. So for example, if you shoot single atoms through two slits with the detection screen on the other side, and you do this repeatedly, these single atoms do not show a pattern like individual particles would, that is, two bands of particles. Rather, they show an interference pattern, like a wave, similar to the pattern that a wave of water would make if going through two slits. This means that the particle going through the slit is either interacting with itself or other particles that are about to be fired but haven't gone through the slits yet. Okay, so this may be a bit weird, but most people can probably accept it, that atoms behave like ocean waves instead of like balls. But what is truly bizarre and unbelievable is that when you try to find out what's going on at the slits by placing a detector there to see what's happening with the atoms, by the way, this is called the which way information. In other words, if you try to detect or observe the trajectory of these atoms, they all of a sudden stop behaving like waves and now behave like particles. And this can be recorded on the screen behind the slits. You might say, well, maybe the detectors are messing with the flow of atoms somehow. Maybe when photons bounce off the atoms and go into the detector, they disturb the atom and collapse its probability wave. But if you keep the detectors there, but turn them off so that no measurement actually gets made, the screen again shows an interference pattern. And as soon as you turn the detectors back on, the interference pattern goes away. So what's going on? Why do atoms and other particles behave this way?